Hello everyone, I'm Karthikeyan and in this video we'll be looking at how to run the decision tree program which uses ID3 in Eclipse, and then we'll be looking at a simple Scala program which is used to find the number of words in a given file, and finally we'll be looking at a Scala program which uses the ML library to generate the decision tree for a given data file. So first we'll look at how we can run the decision tree program using Eclipse. So we'll be following the instructions which are already given to us. In order to import the file, we'll open Eclipse, click on the file and click import button. Into that, we'll click under the general category, we'll select the existing project into workspace and click next. In that, we'll select archive file and choose the downloaded decision tree zip file. Since I already imported the file, I'll go with it. So couple of things to notice here is we'll be given two project files in it. One will be the ID3 and the other will be the org.eclipse.swt file. This is the project that is needed to run the GUI for our program. So we have to check whether it is already present in our build path. For that, we will right click on the project, select the build path option and select configure build path. In that, we must make sure we select the Java build path and select the projects tab. In that, this org.eclipse.swt should be available, and under the libraries, this Weka stable jar should be in the right path. That is, we have to select add jars, and if we open the ID3 example, we'll have the Weka stable jar. We will select that and we'll apply all the settings. Once it is applied, we'll select the GUI.java program and click run. A pop-up window appears. In that, it asks us to select the data file for which we want to run the decision tree. We will use the sample data file which has this data, and we will give the percentage. Say if I'm giving 60%, this will run and it will give us the model accuracy for this particular data file. So these are the additional information that we can check in the console of our program. So next thing, we'll look at how to write a simple Scala program that finds the word count of a given file. So in order to create this problem, we'll click file, we'll create a new project, and in that under Maven, we'll select the artifact coordinates and we'll give the group ID, artifact ID, and a name for our project and click finish. Once we create a project, we'll have a project structure will be like this. In this, since we are using Scala, we are supposed to select and add our framework support. I have already added it. So just to show you guys, I will remove the Scala support and then I'll add it again. Okay, something's wrong. Generally, it will be available here. So you have to select add framework, and here it will show the Scala library. We have to select that and we have to choose 3 jar files for our program like we did in our exercise 4, that is the reflect.jar, library sources.jar. Once you have added it, we'll add the following dependencies for our project, that is the Spark core and Spark MLlib jar files. Once it is added, we will add the build configuration for our program, and the folders under the source will be named as Java. We should rename it as Scala. Once it is done, now I have to create a package by right clicking, giving a new and selecting package. You can give any package name, but make sure you remember that. And we, under that same package name, we have to create a Scala class and it should be of a type object. We'll name it as driver. And in that, this is the code that is used to run the program. Sorry, the word count. We have to set the system property, like where we can find our Hadoop bin files. I have placed it under this folder in my laptop. So, and then we have to give the new Spark configuration, give its name and everything. Once it is done, we are supposed to give the input file name. It will take input file names from command line. So, command line arguments are taken. The first command line argument is the input file, and the second command line argument is the output file. So with this, we can press Maven clean. It will delete whichever targets that has been created earlier, and once it is done, we can create Maven install so that our jar file will be created. So once the jar file is created, you can find the jar file under the target folder here. And once it is created, we'll use the jar file to run the program in AWS. And as we already know, we all know how to create an AWS cluster, EMR cluster. So using the same steps I have created, I have already created a cluster, and I'll be using Putty to connect into it. And I have already added the files acquired in the new S3 bucket. So this Scala sample I have added here. So I'll be running it on two data files. One is the action roles list.txt and the other is manual data. And I'll be using the jar file which I have created now. So once we connect into our we'll log into this. So the first step is to download the jar from our S3 bucket into the EMR cluster. It can be done using the following command, like AWS from S3, copy the file from the given path into the EMR cluster. So once it is done, we'll run the following command, which is in Spark. The class name, we'll give the class name and in which jar file we are going to run it, then the input file name, which is action roles.txt, and then the output folder, which is output underscore action.txt. So once we run the program will run and it will generate the output in the desired given folder. Okay, so the program has run now, and when we reload our bucket, we should be able to find the output file here. So if we open our file, we can see the words. Since we are given comma as the separator, it will separate words based on the separator, and it will generate how many times the words are repeated in the program, in the data file. So we'll run the same program for another data file, which is the mammal data.txt file. So the program is run now. We can check our output folder, and likewise the output file has been generated. We check the output here. Similarly, the word count has been generated. So now we'll look at the decision tree problem. So similarly, we'll be creating a new project, and we'll add the given decision tree driver.scala file, which is available inside the new decision tree program zip file. we have to create the project and then we'll use the same file which is given to us. So this is the program. Similarly, we'll set the system property, that is the path for the Hadoop bin files, and we'll give the input here into the input data.rdd, and once you have given everything, we will run the program. So once it starts running, you should be able to see the output. So for the given data file, it has generated the decision tree. So this is the test error value, and since we are given a maximum depth of 5, it has generated a decision tree for a maximum depth of 5 here. So we can run the same problem again in AWS. We have been already given with the decision tree jar. So similarly, like the previous setup, we'll upload the jar file and the required data files into an S3 bucket, and we can use the same EMR cluster here. Like always, we'll first copy the jar file to our EMR master, and then we'll run the given command. So it will start running, and okay, so our desired output has been generated. Program has stopped executing, and here is our decision tree. In the score we have achieved for the test error, and since it is at a depth of 5, a decision tree of depth 5 has been created. That's all for today. Thank you.